In this video, I'm going to go through the notes for normal distribution. Bear with me as I read through the top paragraph here. So it says, normal distribution is a probability distribution that is symmetric about the mean. Remember, mean is the sum of the data values divided by the number of data values, noted by the Greek letter mu. So it's kind of this funky looking U symbol. The same percentage of data values are above the mean and below the mean. So 50% above, 50% below. Most of the values, about 68%, are within one standard deviation of the mean. Now that's a new term. Standard deviation is a measure of how spread out the data is. The higher the standard deviation is, the more spread out the data is, and vice versa. So smaller the standard deviation, more compact the data is. Standard deviation is shown by the lowercase Greek letter sigma. This one sort of looks like a U with a tail on it. When data is normally distributed, it can be graphed on a normal curve or bell curve or norm, as seen below here. So what you'll notice here is in the middle, we've got our mean, and that's the highest part of our curve, meaning that's where most of the values occur. Other thing to know about normal distribution is that the mean, median, and mode are about equal. So all those values are about the same. We talked about mean. Median is the middle number when the numbers are in order. Mode is the number that appears the most. Other thing that's going to be really important for us this section is about 68% of the data values are within one standard deviation of the mean. So that's this section right here. So you'll see the 1 sigma, or 1 standard deviation above, we've got this line, and then minus 1 sigma, or 1 standard deviation below. So within that section, 68% of the data. Next one, about 95% of the values are within 2 standard deviations. So if we move out one more standard deviation, so we've got a positive 2 sigma over here, so that's 2 standard deviations above, 2 standard deviations below. In that section, there's about 95% of the data. And then the last one, about 99% of the data values are within 3 standard deviations, so we go a little bit further out here. So within that section of the curve, we've got 99% of the values. Now, based on those numbers, we can fill in percentage values for each of these sections here. So if we start with this first one, 68% are within 1 standard deviation. Now what that means is that in each of these first 2 sections are 34% of the data. So from the mean, 1 standard deviation above is 34, and one standard deviation below is 34%. All right, based on the second one, 95% of the data are within these 2. So what that actually means, I'll do the math for you here, is that that's got to be 13.5% of the data, and that little section is going to be another 13.5% of the data. And then with this last one, we can actually fill in a couple of things here. The first one, if 99% of the data is within these 2, then this little section is going to be 2%. That section is 2%. And then these kind of outliers here, we're going to have 0.5% that are above 3 standard deviations and 0.5% that are below. Now, we're going to be using this curve to answer the questions that follow. So every time we have a different set of data, we're going to create this bell curve, or this normal curve, and then we're going to fill in some numbers on the bottom, and that'll help us answer our questions. So let's move on to that. So I've got a blank bell curve here, and I'm going to go through and I'm going to fill in my percentages again. So I've got 34%, 34%. If we were doing this in the classroom, at some point you would need to memorize those percentages, but given that we're doing this remotely, you'll have access to your normal curve right in front of you here. So we got 0.5% there, 0.5% there. All right, so we're using that same curve for every different group of questions. The only thing that will change are the numbers that are on the bottom. So let's take a look at some examples here. All right, the first one says the heights of players in a basketball league are normally distributed with a mean of 6 feet 1 inch and a standard deviation of 2 inches. So we're going to take those two values, and those two values are going to help us fill out our number line here. So 6 feet 1 is our mean. That means that value goes in the middle where our mean is supposed to be. And then we use our standard deviation to find our other values. Going to the right, we're going to take our standard deviation and add that continually to the numbers. So if I add 2 inches to 6 feet 1, I get 6 feet 3. If I add 2 inches to that, we get 6 feet 5 inches. 2 inches to that, we get 6 feet 7 inches. Going the other way, we subtract 2 inches from that. So if I'm at 6 feet 1 and subtract 2 inches, that's actually going to bring us to 5 feet 11 inches. Subtract 2 inches again, we get 5 feet 9 inches. Subtract 2 inches again, we get 5 feet 7 inches. All right, so that brings us to the questions that you're going to be asked. Now, there's going to be one of three different types of questions. It'll either say what probability, or what is the probability. It might say something like what percentage of things or people fit into this category, and then we'll see one a little bit further down how many of a certain person or category fit in. So let's start with the first one here. So it says, what's the probability that a player selected at random will be shorter than 5 feet 9 inches? So what you have to do is you have to locate that value on your number line. If you don't find it on your number line, that means you've done something incorrectly. Okay, so we've got 5 feet 9 inches here. Now, shorter than 5 feet 9 are going to be going to the left. So if I'm going to take all the values that are shorter, I simply add up each of the sections that are below that. In this case, these two. So 2 and 0.5 means that 2.5% of the players are shorter than 5 feet 9. And that's it. That's your answer to the first one. Question 2, what is the probability that a player selected at random is between 5 feet 11 inches, so 5 feet 11, and 6 feet 5. So this time I've got to find both of those values and count up all the sections that fit in between both of those values. So here's 5 feet 11, and here's 6 feet 5. So I've got those two. I've got to add up those three sections. So if we take and add 34, 34, and 13.5, you don't actually have to write this down. I can trust that you can either do this on a calculator or in your head. You're going to get 81.5% of the players fall between those two heights. All right, moving on to part C. So part C says, if there are 240 players in the league, about how many players are taller than 6 feet 3 inches? So we're not looking for a percentage anymore like we were in the previous ones. We're looking for how many players. But we do have to come up with what percentage of the players in the league are above 6'3". So we go to 6'3", and then we add each of those three sections. So 13.5 plus 2 plus 0.5, that comes out to 16%. That means I need to take 16% of 240. Easiest way to do that is take the decimal version of 16%, which is moving the decimal 2 places to the left, or 0.16, and we multiply that by 240. So 0.16 times 240 comes out to 38.4. Now, generally we don't talk about people being in a decimal part, but I'm going to let you either answer it exactly as it appears. So I would actually be okay with you saying something like 38.4 players, or if you want to approximate, that's fine as well. So if we want to say about 38 players. Okay, again, notice we don't have a percentage there. So you got to go one further step and actually find the percentage of the total number of people, or could be things, in that category. All right, moving on to the next group of questions. It says, the number of eggs laid per year by a particular breed of chicken is normally distributed with a mean of 225 and a standard deviation of 10 eggs. So I'm going to cross these out. You don't have to cross them out. You could just write it underneath. But I'm going to cross them out, and I'm going to rewrite my number line here. I'm going to start with my mean of 225 in the middle. And then I'm going to add 10 eggs going to the right. So 235, 245, 255. And then subtract going to the left. So 215, 205, and 195. Okay, so that's my new number line. I'm going to be asked a lot of different questions again, or similar questions. First one says about what percent of the chickens lay between 215 and 235 eggs. So going back up to my curve here, I got 215 and 235. I'm going to add those two percentages, so 34 and 34 means that 68% fall within that range. If I look at my next question, if a flock of 400 chickens, or in a flock of 400 chickens, about how many would you expect to lay more than 245 eggs per year? So here's 245. I add those two sections up, going to the right because that's greater than. So I need to find 2.5% of 400. And this is going to be not 0.25, but 0.025 multiplied by 400. 0.025 multiplied by 400, and that comes out to exactly 10 chickens. So that's what you'd expect based on the previous information. All right, last group of practice questions here. The diameter of bolts produced by a manufacturing plant is normally distributed with a mean of 18 millimeters and a standard deviation of 0.2 millimeters. So again, I'm going to cross out these previous values. I'm going to put 18 in the middle and then add 0.2 going to the right. So 18.2, 18.4, 18.6, and then subtract going to the left. So 17.8, 17.6, 17.4. And then we answer the questions the same way. Question A, what percent of the bolts coming off the assembly line have a diameter greater than 18.4? Here's 18.4, so greater than is above. We're at 2.5%. You'll notice that as you're doing these, a lot of the same answers come up quite a bit because you only have so many combinations of adding things together. So you'll see 2.5, you'll see 16, 34, 68, those sort of things. And then about what percent have a diameter between 17.8 and 18.2. So we got 17.8 to 18.2. We add those percentages up and we get 68%. And that's about it. It doesn't get a whole lot more complicated than that. Based on your mean and standard deviation, you're going to create your normal curve. And when you see the homework, you'll see that you've got a blank normal curve to work with. Make sure you add your percentages in there. And then you'll be asked, as I said, one of three different questions. What's the probability? Or what percent of something or people fit into a certain category? Or how many in a certain category? So hopefully that'll get you started with that. As always, contact me with questions, and a quiz will follow after that.